This is Keith here again from Hyde Motorworks. Got some new stuff for the M1 kit. This is a prototype discharge pan for the M1, which will fit the M1 22H supercharger and the TVS supercharger. And there's a few twin screws that could also be mounted on it. It's made out of aluminum instead of steel, so it's 1/3 of the weight, but just as strong. Also increased the output flange to 3 inches rather than 2.5, is what the original one was. Like I said, this is just a prototype, so all I did was throw some black paint on it. The final version will be even neater than this, and will be PE coated. You can see the collection part of it is more directed to flow the air out of the discharge pan, but it still extends to the back, so that way we can use the built-in bypass valve on the supercharger. And these are cams that I just got from VAC Motorsports. It's their aggressive profile supercharger cams. One of the problems with the other cams I was using was there wasn't enough exhaust duration. These are, the intake is 264 duration, and at 10.6 millimeters lift, and the exhaust cam is 270 degrees of duration at 10.8 lift. The idea is to try to get a little bit more out of the top end, the higher part of the mid-range on up. The other cams that I was using had plenty of low-end torque, but when I got up into the higher RPM range, the horsepower kind of flattened out, which, I mean, it drives nice like that. I mean, it made 350 foot-pounds of torque at 2100 RPMs or 2200, which was nice, except for blowing axles out. But I'm trying to get a little bit more on the top end. And one of the things I noticed with the dyno runs that we did was that where the horsepower should have been really taking off, the boost increased. It increased from 14 to 15 pounds, like at 4,000 RPMs, and it shot up to a little over 18 at about 4,500, coming up on 5,000 RPMs, which with a positive displacement blower is odd. Typically the boost gets up to where it's set to and kind of maintains throughout the RPM range, but I saw the boost jump way up. And looking at more data and checking back pressure on the exhaust, it wasn't an exhaust system problem. The Raceland headers and the rest of the exhaust did a good job. I didn't have a very low back pressure, but the numbers didn't match up, and that's when I realized that I really didn't have enough time on the exhaust side to get all the exhaust gases out. On an NA engine or even a turbo setup, having high exhaust velocity can be very beneficial. With NA, high exhaust velocity helps promote combustion chamber scavenging on overlap. High exhaust velocity with a turbo will help spool a turbo up faster. On a supercharger, especially positive displacement, you really don't want high velocity. You want to get the exhaust gases out of there as quickly as possible. So I believe this exhaust cam was going to make a huge difference. The 264 at a little over 10 mil lift It's very similar to the cams I had in there, but I believe I had 256 on the exhaust side. And that's where the problem was and why it didn't really, the top end didn't really take off like it should. So I'm going to put these cams in. I have the lifters soaking in oil. Got another new set because, well, why not? Even though the other cams, I did have new lifters with them and they didn't even have 1,000 miles on them. It's always a good idea to replace the lifters with new camshafts, so that way you don't cause any premature wear on the cams, because they're following where the original cams were with old lifters. Yeah, I mean, they're a little pricey. I mean, you're going to pay, I think I paid like $500 or something for this set of lifters. The cams with shipping came to about $15. So yeah, it's an expensive investment. Not to say that the stock cams can't perform. They will perform very well, especially in the low and mid range of the engine with the supercharger. What this is where you want to make sure the rest of your drivetrain is solid, because there will be a huge increase in torque. But these cams should not hurt the torque production down low, but I should get quite a bit more top end power out of it. I'd like to be able to, it should be able to rev out to 7,500 RPMs. Not that I would do that constantly, but it's nice to know that it'll keep pulling up that far. But I guess I'll put them in, and I'm going to use the prototype discharge pan this time. I always like to test them and make sure that everything is right. On the other side, I do have an extra fitting in there. I like to check boost pressure at the pan as well as at the intake to make sure I don't have any restrictions that I might have overseen when designing it. I should see a slight pressure drop between the supercharger and the intake manifold while it passes through the intercooler. When you cool the charge temperature down, the air is more dense, so there should be a little bit of a drop, but it should not drop a tremendous amount, especially at higher RPMs and higher airflow. I should see a pretty steady pressure differential. Okay, that's it for now.